Hello, hi everyone. Welcome to the Student Brand. So today I'm going to discuss about light reflection and diffraction. So let's start. Light reflection and diffraction. Light light reflection and diffraction. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So here I'm considering this is a plane mirror. This is a plane mirror. Okay. So here you can see this is incident ray, reflected ray, incident ray, reflected ray, and the line which is perpendicular to the plane surface is called normal line. So here you can observe this is a normal line. So incident ray, and reflected ray, and normal. So the total phenomena, the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So here you can see the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. So this undeviated line, okay. So the angle between reflected ray and undeviated line is called angle of deviation. The light which is incidenting on the surface is called incident ray. So here this is the incident ray. The light which is incidenting on it, so incident ray. The light which is reflecting back is called reflected ray. And the line which is perpendicular to the plane surface, this is surface. So which is perpendicular to the plane surface is called normal line. And this line is dotted line. So which is okay, undeviating. So this line is called undeviated line. Okay. So now we can see the linear angle. So I'm taking this linear angle. Linear angle is 180 degrees. Linear angle is 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. From loss of reflection, angle of incidence plus, so coming to loss of reflection, so we'll discuss about loss of reflection. Loss of reflection. So what are the loss of reflection? Loss of reflection are nothing but loss of reflection, loss of reflection, loss of reflection. Okay, so first point is incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Okay, so now second point is so angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Here you can observe. So this is the incident ray, reflected ray, normal line. Okay, so here you can observe incident ray, reflected ray, normal line. So all lies on the same plane. Okay, so at point of incident. Okay, and here angle of incidence. So the angle between incident and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. So angle of incident is equal to angle of reflection. So this is about loss of reflection. Now from this, so you can observe here. So this is the linear. This is completely linear angle. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees because it is a linear angle. So you can take you can observe here. linear angle is 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. From laws of reflection, we know that angle of incident is equal to angle of reflection, right? Angle of incident is equal to angle of reflection. So we can write here angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Okay, so we can take angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of incidence. Okay, so here we can observe from this one, from angle of incident is equal to angle of reflection. So from here we can also write, instead of angle of incident we can write angle of reflection. Angle of reflection plus angle of reflection plus angle of deviation equal to 180 degrees. So now angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So I hope it is very clear. You can observe here. Once again, the light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is perpendicular to the plane surface is called normal line, because so it is dotted line. So this is the dotted line. So that is a normal. The angle between incident and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Okay, so here this completely entirely linear angle 180 degrees. So that's why I'm taking angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Okay, so here, so this is a linear angle, right? So linear angle how much? Half circle. Normally if you are taking this is the complete circle, so half circle is 180 degrees. Half circle is 180 degrees. Okay, so that's why it is linear angle. So this is the linear angle. That's why I'm considering like this. Half circle we can take it half circle. So this completely angle is 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, so then we can take angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. So the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So here you can observe, so the light which is incidenting on the surface and reflected back, the entire phenomenon is called reflection of light. So the bouncing back of the light from the reflecting surface is called reflection of light. Okay, so this is about reflection and angle of incident and angle of reflection, everything. Now so we will discuss about regular reflection and irregular reflection. Regular reflection, regular. So what is a regular reflection? Regular reflection is nothing but, so I'm taking the plane surface. So this is a plane surface. Okay, this is a plane surface. So all incident light rays are parallel, then reflector light rays are also parallel to each other. So that type of reflection is called regular reflection. So here you can observe, these are the incident light rays. These are incident light rays. So you can observe here, these are all incident light rays. Okay. So these incident light rays are parallel to each other. So these all light rays are parallel to each other. After reflection also, if the light rays are parallel to each other, then this type of reflection is called irregular reflection. Sorry, regular reflection. Regular reflection means incident light rays are parallel. After reflection, reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Now we will discuss about irregular reflection. Irregular reflection. Irregular reflection. So irregular reflection. Incident light rays are parallel, then reflector light rays are not parallel to each other. So incident light rays are parallel, but reflector light rays are not parallel to each other. So here you can observe, this is the irregular surface. Irregular surface. Okay. Now, so I am considering here like this. You can observe. So these are the incident light rays. These are incident light rays. Here I am taking like this. Okay. So incident light rays are parallel, but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. So here you can observe. Here you can observe. Incident light rays are parallel. Incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. So regular reflection means, so here you can observe incident light rays are parallel to each other, and reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. But coming to irregular reflection, incident light rays are parallel, but reflector light rays are parallel to each other. So these light rays are moving in different directions. So these are all reflector light rays. Reflector light rays are moving in different directions. Okay, regular reflection and irregular reflection. Regular reflection takes place on smooth surface, still water, and a plain surface, we can say. Coming to irregular reflection, a rough surface, and we can take a wall. Okay, so book also, paper. So irregular reflection takes place. So surface, rough surface we can take, rough surface. Okay, so that is about regular reflection and irregular reflection. And related to this one, they will ask one question. So plane mirror also reflect light rays and wall also reflect light rays. So what is the difference? So plane mirror reflect regular reflection. So regular reflection takes place on plane mirror, whereas on wall irregular reflection takes place. Irregular reflection takes place. So this is about regular reflection and irregular reflection, right? Yes. Now, so now we will discuss about image and object. So I'm taking here. So here I am considering light rays are coming from the source. These are light rays. After reflection, the light rays are meeting at one point. Here you can observe these are incident light rays. So 1, 2. So these are incident light rays. 1, 2. So I1, I2, R1, R2. Okay, so these are incident light rays. So we are extending these incident light rays. We are extending this one. So here image is forming. This is a real image, virtual object. So here you can observe, in this case you can observe, so incident ray 1, incident ray 2. So after reflection, this R1 and this one R2. So after reflection, light rays are meeting at one point. Okay, so this is the real image. Real image. So incident rays. So we are extending these incident light rays. We are extending these incident light rays. So after extending, the light rays are meeting at one point. Those light rays are meeting at one point. So their image, their object is there. That is a virtual object. So here you can observe this is a virtual object. So I1, I2, R1, R2. So after reflection, these light rays are meeting at one point. Okay, this is a real image. Okay, so directly reflected light rays are meeting at one point. Then that image is called real image. So here you can observe we are extending these incident light rays. Extended incident light rays are meeting at one point. Extended. So extended incident light rays are meeting at one point. Their virtual object is formed. Okay. And here you can observe. Here you can observe from this point. From this point. So light rays are coming. So this is a real object. So from that point, light rays are coming. Okay. So these are the incident light rays. So I1, I2. So this is I1 and I2 and this one is R1 and this one is R2. Okay. So I1, I2 light rays are coming from the point. Okay. Here you can observe light rays are coming from this point. After reflection, light rays are moving away from the mirror. So this one is the mirror. Okay. So you can observe this one is the mirror. Mirror. And this one also mirror. Okay, this one is the mirror. So the middle point one is the mirror. So here you can observe after reflection. Here you can see we are extending the incident light rays here. Extended incident light rays are meeting at one point. Their virtual object is formed. And here you can observe from here this is a real object. Real object. From this one light rays are coming I1, I2, R1, R2. We are extending this one. R1 we are extending, R2 we are extending. Those light rays are meeting at one point. Okay, so their image is forming. That's a virtual image. So mirror. Object is real, image is virtual. Object is virtual, image is real. Once again, object is virtual, object is real. Object is real where? This is a real object. Real object. And the image is virtual. Virtual image. Object is virtual. Where is object is virtual? Here is object is virtual. So and the image is real. Where is the image is here? Okay. If the object is real, image is virtual. If the object is virtual, image is real. Okay, in the plane mirror. So very important. Make sure that you are learning these points. Okay. So very important. So this is about image formations. So image of the types of images. Okay. Next one we will discuss about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror will discuss. Now, nature of the image formed by the plane mirror. So I am considering here this is the plane mirror. Okay, so like that I am considering here. So this is the object, height of the object and size of the object. So AB is the height of the object. I am taking one light ray like this after reflection. So normally here, if the light ray is passing along the normal line, so what happens? If the light ray is passing along the normal line, it retraces its original path. If the light ray is passing along the normal line, so it retraces its original path. It moves in the same direction. Here also same thing. If the light ray is passing along the normal line, so it retraces its original path. It retraces its original path. So here like this. And one more I am taking like this. So here I am considering after reflection that light ray is moving away from it. So this is incident light ray. After reflection, light ray is moving away from it. Okay. So here also I'm taking one more here, and this one is reflecting, and here you can take. So here you can observe. So here if you are extending these light rays, and here also if you are extending, and here you are taking here. Okay, so like this here. So this is A dash and B dash. A dash and B dash. So here, if the light ray is passing along the normal, it reflect back into the same path. Okay. Here also same thing. This is the object and image. So here, now what are the characteristics of the image formed by the plane mirror? So now we will discuss those points. Point number one. Point number one, object is real, image is virtual, image is real. Point number one, object distance is equal to image distance. So the distance between object, so this the object, okay. So this the object and this one is the mirror. This middle one is the mirror. So this object distance and the distance between image. So this the image. Okay, so this one is the image and this one is the mirror. So this is the image. Okay, object distance is equal to image distance. Object distance is equal to image distance. And the third one, height of the object equal to height of the image. Height of the object is equal to height of the image. Okay, so magnification of the plane mirror is +1. Magnification of the plane mirror is +1. So magnification, if you are taking m equal to +1, magnification. So height of the object is equal to height of the image. So and the next one more point. It also shows lateral inversion. Lateral inversion. Lateral inversion. So what do you meant by lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image and left side of the object appears to be right side of the image. So if you stand in front of the mirror and lift your right hand, it appears in the left side. If you lift your left hand, it appears in the right side. So that phenomena is known as lateral inversion. Lateral inversion. So this is about characteristics of the image formed by the plane mirror. Once again we will discuss. So point number one, object distance is real. So object is real, image is virtual. Object is virtual, image is real. So point number one. And point number two, object distance. So this is the object. Okay, so this is the object, and this one is the image. So object distance is equal to image distance. And height. So this is nothing but height or size. Okay, size of the object is equal to size of the image. And also magnification is nothing but height of the image by height of the object. That is nothing but, so here in plane mirror, so object is virtual erect image will form. That's why magnification is +1. So here in plane mirror we'll get magnification is +1. In concave mirror also we'll get magnification 1 but minus. Concave mirror minus, here plane mirror +1. So lateral inversion. What do you meant by lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This mirror image is called lateral inversion. So this is about characteristics of the image formed by the plane mirror. Characteristics of the image formed by the plane mirror. I hope it is very clear. So this is about image. And the next one, so we will discuss about spherical mirror. So we will discuss about spherical mirrors. There are two types of mirrors, spherical mirrors. So spherical mirror. First one is concave mirror. Concave mirror. And the second one is convex mirror. Convex mirror. Convex mirror. Convex mirror. So what is concave mirror? Concave mirror is nothing but the mirror whose reflection takes place inward. The mirror whose reflection takes place inward. That is called concave mirror. Whenever light rays are incidenting on it, so here you can observe after reflection, those light rays are moving towards the principal axis. So here you can observe this mirror, concave mirror, after reflection, light rays are moving towards the principal axis. Light rays are converge. So light rays are converging. So whereas convex mirror. So this is called concave mirror. What is this one? Concave mirror. What is this one? Concave mirror. Concave mirror. What is this one? Concave mirror. Next one, convex mirror. 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 What is a convex mirror? When light rays are incidenting on it, it reflects light rays. What is happening? Convex mirror. What convex mirror is doing when light rays are incidenting on it? Light rays are incidenting on it after reflection. After reflection, light rays are moving away from it. That's why we are calling convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. What is called? Diverging mirror. Why convex mirror is called diverging mirror? When light rays are incidenting on it, after reflection, light rays are moving away from it. That's why it is called convex mirror, also known as diverging mirror. Convex mirror is also known as diverging mirror. Why concave mirror is converging mirror? After reflection, light rays are moving towards the principal axis. After reflection, light rays are moving towards the principal axis. That's why, oh my God, that's why it is called concave mirror. Coming to diverging mirror, after reflection, light rays are moving away from the principal axis. That's why it is called diverging mirror. Diverging mirror, concave mirror, converging mirror, convex mirror, diverging mirror. So this mirror comes under spherical mirror. What do you mean by spherical mirror? Spherical mirror is nothing but the mirror which in the form of curved shape. The mirror which in the form of curved shape is called spherical mirror. There are two types of spherical mirrors, concave mirror and convex mirror. Concave mirror. So reflector light rays will move towards the principal axis. Here you can observe reflector light rays are moving away from the principal axis. That's why concave mirror is called converging mirror. Concave mirror is called converging mirror. Coming to convex mirror. Convex mirror is called diverging mirror. Convex mirror is called diverging mirror. So this comes under spherical mirror. This comes under spherical mirrors. Very good, very good, very good. Next we are going to discuss about Terms related to spherical mirror. Terms related to terms related to spherical mirror. Come on. ఇప్పుడు so now we are going to discuss terms related to spherical mirror. అయ్యో okay, what we took concave mirror, what we consider concave mirror. How can you say concave mirror? Because reflection takes place inward. So coating will be outside. That's why it is called concave mirror. That's why it is called concave mirror. The center of the imaginary sphere in which mirror is a part is called center of curvature. The center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The line joining the principal center of curvature and pole. The line joining the center of curvature and principal axis called center of curvature and pole. The line joining of center of curvature and pole is called principal axis. What is this called? Principal axis. Come on. What is this called? Principal axis. That is called principal axis. The center of the imaginary sphere in which mirror is a part is called center of curvature. The center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. Come on. The distance between. So the distance between, here we go. Now we are going to discuss about the distance between center of curvature and pole is called. What is that? Radius of curvature. The distance between center of curvature and pole is called radius of curvature. After reflection, all light rays are meeting at one point of the principal axis called focus. After reflection, all light rays are meeting at one point on the principal axis called focus. The distance between focus to pole is called. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And width of the mirror is called aperture. Width of the mirror is called aperture. Come on, everyone. The center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. Principal axis. The line joining of center of curvature and pole is called principal axis. So the distance between center of curvature and pole is called radius of curvature. After reflection, all light rays are meeting at one point on the principal axis is called focus. The distance between focus to pole is called Focal length, the distance between focus to pole is called focal length. Here you need to understand one thing, the difference between focus to pole. Capital letter will be written for focus, small letter will be written for focal length. Ay, 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 ay. Oh, focus, focus. So focus will be written with capital letter. Focal length, focal length, focal length will be represented with a small letter, small letter. What is focus? After reflection, light rays are meeting at one point on the principal axis. Principal axis. After reflection, light rays are meeting at one point on the principal axis called focus. The distance between focus to pole is called focal length. Width of the mirror is called aperture. Aperture. Width of the mirror is called, reflecting surface is called. So this is the reflecting surface. So this surface is called aperture. So we can denote with M and N, M and N. Aperture. Aperture. So center of the imaginary sphere is called center of curvature. Midpoint of the mirror is called pole. The distance between center of curvature and pole is called principal axis. The distance between the line joining of center curvature and pole is called principal axis. This line is called principal axis. The distance between center curvature and pole is called radius of curvature. The distance is radius of curvature. Line joining is principal axis. I hope it is very clear. So line joining is principal axis, distance is radius of curvature. After reflection, all light rays are meeting at one point on the principal axis called focus. The distance between focus to pole is called focal length. Width of the mirror is called aperture. Width of the mirror is called aperture. Width of the mirror is called aperture. Aperture. So now we are going to discuss about ray rules of concave mirror. Ray rules of concave mirror. Concave mirror. Ray rules of concave mirror. Concave mirror and convex mirror. Concave mirror, convex mirror, concave mirror, convex mirror. Okay. Everybody, are you ready? Come on. Ay. Oh, now concave mirror. Concave mirror. Concave mirror. Concave mirror. Concave mirror. Convex mirror. Convex mirror. Convex mirror. Okay, so first ray diagram is, so when you are mentioning every time you must represent all the points. So pole, focus, center of curvature. So light ray is coming from infinity. After reflection it passes through focus. Light ray is coming from infinity. Oh. Light rays is coming from infinity. After reflection it passes through focus. Second one. Oh. Light rays passing through pole, Focus, center of curvature. Light rays passing through focus. After reflection, it is moving towards the principal axis. So third one. Dun, 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 na, 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 na. Pole, focus, center of curvature. Light ray is passing through center of curvature. After reflection, it retraces its original path. Ay, 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 ay. Ay, 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 ay. So much is happening. So, pole, focus, center of curvature. So, light ray is incident at the pole. After reflection, light ray is incident at the pole. After reflection, it reaches. So, it moves into the same medium. Concave mirror. Ay, 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 oh. Ay, ay, oh. What's happening? How much it happened? When light ray is coming from infinity, after reflection passes through focus. Light ray is passing through focus, after reflection moves towards infinity. Light ray is passing through central curvature, it retraces its original path. Light ray is incident at the pole, it reflects back. So coming to convex mirror, convex mirror, diverging mirror, concave mirror, converging mirror, converging mirror. So every time you are drawing, you have to mention pole focus, center of curvature, pole focus, center of curvature. Light ray is coming from infinity. After reflection, light ray is coming from infinity. After reflection, it passes through focus. Ay, 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 ay. Oh, second one, light ray, ay, 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 oh, ay, oh, pole, focus, center of curvature, light rays passing through focus, it after reflection, it is moving towards infinity. Here you have to understand one thing. If the light is coming from infinity, after reflection passes through focus. We are extending the reflector light ray. Extended reflector light ray is passing through focus. Here, this is the incident light ray. Light ray is coming from also. So after reflection, it is moving parallel to the principal axis towards infinity. Okay. So if you're extending, it passes through focus. And coming to third one, ayyo. So pole, focus, center of curvature, light rays passing through center of curvature. It retraces its virgin. Oh my god. So it retraces its original path. It reflects back into the same medium, same path, same path, same path. It is happening when light rays incident at the pole. Focus, center of curvature, light rays inside the pole, it reflect back. It reflect back. So all of you, are you listening or not? Here you need to understand, observe carefully here. Concave mirror, convex mirror, ray rules we are discussing. Light rays coming from infinity. After reflection passes through focus. Light rays passing through focus. After reflection moves towards infinity. Light rays passing through center of curvature. It retraces its original path. Light rays incident at the pole. It reflect back. Convex mirror, convex mirror, diverging mirror, convex mirror, diverging mirror, concave mirror, converging mirror. Here, light ray is coming from infinity. After reflection, it moves, it passes through focus. Light ray is passing through focus. After reflection, moves towards infinity. Light ray is passing through center of curvature, it retraces its original path. Light ray is incidenting at the pole, it reflects back. So this is about concave mirror. Concave mirror is also known as converging mirror, convex mirror is also known as diverging mirror. We discussed till now ray rules of concave mirror and convex mirror. Now we are entering into discussion of image formation, image formation. Image formation of concave mirror and convex mirror. Everyone do like, share and subscribe to Student the Brand. Student the Brand. Student the Brand. Concave mirror, converging mirror. So image formations of concave mirror. Concave mirror image formations. So everyone be ready. So let's start to discuss about concave mirror image formations. Are you all ready? If you are ready, do like, share and subscribe to Student the Brand IAS. Subscribe. Student the Brand, subscribe everyone. So you won't miss latest updates. You won't miss latest updates from Student the Brand. So I'm taking here light line, pole, focus, center of curvature. Object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. One light ray I am taking like this. After reflection, those light rays are meeting at focus. Object is at infinity, image is forming at focus. Object is at infinity, image is forming at focus. Nature of the image is real and inverted, and highly diminished. So here you can observe object is placed at infinity. Image is formed at focus. Nature of the image is real and inverted. So because here point size image is forming at focus, that's why it is highly diminished. And next one you can observe. Next one, object is placed beyond center of curvature. Object is placed beyond center curvature. Object is placed beyond C. Image is forming between C and F. Nature of the image is real and inverted. Size of the image is diminished. Ay, 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 oh, array, ay, 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 array. Size of the image is diminished. Object is placed beyond center of curvature. Image is formed between center of curvature and focus itself. Oh my God. Coming to third one. Pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed at the center of curvature. Object is placed at the center of curvature. Center of curvature. Center of curvature. Center of curvature. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Oh, how many light rays? Minimum. Come on, everybody say how many? Minimum 2 light rays. Oh, how many? Minimum. How many light rays are required to form the image of the object? How many? Minimum 2 light rays are required to form the image of the object. Object is placed at C, image is formed at C, nature of the image is real and inverted, size of the image is same size, same size, same size. So, object is placed at C, image is formed at C, nature of the image is real and inverted, and size of the image is same size. So, size of the image is very, very important. So, make sure that you are remembering this point. So, real and inverted, nature of the image, real and inverted is very, very important. If object is placed at C, only these cases. So, there is a special case in concave mirror because so the minimum distance between object and real image is 0 here. So, virtual image also there, but here we are talking about real image. So, the minimum distance between object and its real image is 0. So, here because object and image is placed at one point. Okay, object is placed, image is formed at one point. Real and inverted and same size. And sorry. Coming to fourth one. Object is placed between C and F. How many light rays are required to form the image of the object? Minimum. 2 light rays are required to form the image of the object. How many light rays? Minimum 2 light rays. How many light rays? Minimum 2 light rays are required to form the image of the object. Minimum how many? 2 light rays. Minimum how many? minimum. Very minimum. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Object, where is object is placed between C and F, where image is forming beyond central curvature, where image is formed beyond central curvature. Everybody say with me, object is placed between C and F, image is formed beyond. Beyond central curvature. Nature of the image is real. Real and inverted. Real and inverted. And size of the image is yellow. Come on. Image is real inverted and enlarged. What is image? Object is placed between C and F, where image is formed beyond central nature. What is the nature of the image? real inverted and enlarger. Real inverted. Abba. Real inverted and enlarger. What an image. What an image. Object is placed between C and F. Image is found between beyond C. Nature of the image inverted. What about size of the image? L large. Size of the image is L large. So next one, fifth one. Come on, everybody, come on. Object. Come on. Object is placed at focus. Object is placed at focus. Oh my god, come on. Really? Oh, great. How are you? How it is possible? Object is placed at focus. Okay, image is formed at infinity. Nature of the image is real and inverted. And size of the size of the image is highly enlarged. Size of the image is highly enlarged. Come on, sixth one. Sixth one is very important. Sixth one is very important. If the object is placed between F and P, where image will form pole, focus, center of curvature. Object is placed between F and P. Object is placed between F and P. Image is formed behind the mirror. Come on. Where image will form behind the mirror. What is the nature of the image? Virtual, erect and enlarged. Where object is placed between F and P, where image is formed behind the mirror. 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 What is the nature of the image? Nature of the image is virtual, erect, and size of the image is enlarged. Enlarged. Because why? Because object is placed between F and P. Object is placed between F and P. So automatically image will form behind the mirror. What is the nature of the image? Virtual, erect, and enlarged. Object is placed at infinity. Image is formed at focus. So nature of the image is real and inverted. Everyone should remember this point. This point is very important. Why? Because object is placed at infinity. Image is formed at focus. Nature of the image is real and inverted, and size of the image is highly diminished because point size image is forming at focus. Into second one, object is placed beyond center of curvature. ఎంత పని జరిగిపోయింది. ఆబ్జెక్ట్ ఈస్ ప్లేస్ బియాండ్ సెంటర్ ఆఫ్ కర్వేచర్. తర్వాత ఇంకా image is formed between C and F. What is the nature of the image? Real and inverted. What is size of the image? Diminished. Oh my god, it is diminished. Object is placed at C. Image is formed at C. Nature of the image is real and inverted. What is the size of the image? Same size. Object is placed at C. Image is formed at C. Nature of the image is real and inverted. And the size of the image same size. So coming to fourth one. Coming to fourth one, when the object is placed between C and F. Object is placed between C and F, where image will form beyond center curvature. Object is placed between C and F. Image is formed beyond center curvature. Nature of the image is real and inverted and enlarged. Size of the image is enlarged. Coming to fifth one. Object is placed at F, where image will form at infinity. What is the nature of the image? Real and inverted. Size of the image is highly enlarged. Oh my god. Object is placed between F and P. Image is formed behind the mirror. Nature of the mirror is virtual, erect and enlarged. What is the nature of the image? Virtual, erect and enlarged. Virtual, erect, enlarged. So this is about concave mirror image formations. Now we are going to discuss convex mirror image formations. Convex mirror image formations. So what is that? Convex mirror image formations. Convex mirror image formations. Convex mirror image formations. Oh my god. Oh god. Oh my god. Convex mirror image formations. Convex mirror image formations. So are you all ready? So let's start. Convex mirror. So convex mirror is also known as converging or diverging mirror, because light rays are incidenting on it, after reflection those light rays are moving away from the principal axis. So I am taking here pole, focus, center of curvature. So light rays are coming from infinity, after reflection light rays are moving away from the principal axis. So object, everybody say object, where object is placed at infinity, where image is formed at focus. What is the nature of the image? Virtual, right? Virtual array and highly diminished. Highly diminished. Highly diminished. Highly diminished. Highly diminished. Highly diminished. So pole, focus, center curvature. Pole, focus and center curvature. Object is placed. Object is placed. Object is placed. Object is placed. Okay. So object is placed. Object is placed. Object is placed. To object is placed. So it is passing. Object is placed between infinity and pole. Nature of the image is forming between P and F. P and F. Nature of the image is virtual, erect and diminished. So diminished. Ayyo. Arre. Diminished. What is this image? Diminished. What type of image it is? Diminished. What type of image it is? Diminished. Oh my god, really great, amazing, extraordinary, marvelous. Mind blowing. Okay, great. So here, object is placed at infinity. Image is formed at focus. What is the nature of the image? Virtual, erect, and highly diminished because point size image is formed at focus. So next one. So object is placed between infinity and pole. Object is placed between infinity and pole. Where is it? So where image is forming between P and F. What is the nature of the image? Virtual, erect, and diminished. Because in convex mirror, if you place any object in front of it, we can see the full view of the image, full view of the object, full view of the object. Even if you are standing, so if you place any object in front of it, we can able to see. So that's why, because of that property, so because of larger field view, okay, so coming to plane, compared to plane mirror and concave mirror, so for convex mirror, field view is more. What is field view? So within this range, so until here, until this range, so the region between two extreme reflector light rays, the region between two extreme reflector light rays is called, okay, or ends of the reflector light ray. So here until beyond that point there is no reflection. Here also beyond this point there is no reflection. So within this region, so if you place any object, we can able to see. That's why that is called field view. For plane mirror, for concave mirror, compared to convex mirror, so it will be less. For convex mirror only, it will be more. Okay, field is more for convex mirror. That's why we are using rear view mirror. So like, okay, so that's enough. To see the traffic, we are using as a rear view mirror in the cars, bikes. Okay, done. Now, so mirror formula and magnification. So I'll discuss. So now we are going to discuss about mirror formula. So sign conventions we have to discuss. Sign conventions are very important. So after that, mirror formula, lens formula. So here you can take the concave mirror. This is a concave mirror pole, focus, center of curvature. So all measurements will be taken in the direction of incident rays. So all are positive in this direction. Opposite to incident rays negative. Above the principal axis it is positive. Below the principal axis it is negative. Okay. So all measurements will be taken in the incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all are positive. Height of the image, height of the object. Below it is negative. So this will be converted in the form of song. So just for learning in easy way, I converted into song. So new Cartesian sign convention, new Cartesian sign convention, all distance are measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So likewise, so given the song, all measurements will be taken from the pole. All measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. So this is about image for sign conventions of mirror. Now we will discuss about mirror formula and magnification. So mirror formula 1 by f equal to 1 by v plus 1 by f equal to 1 by v plus 1 by u, and magnification is so height of the image by height of the object, that is nothing but so minus v by u. So this is about magnification, so mirror formula and magnification. Okay, so I hope it is very clear. So that's enough. So light refraction we have to discuss. It will take nearly 1 hour. So I'll explain slowly one by one. So thank you so much for joining, attending and listening my class. Do like, share and subscribe to Student in the Brand. This is your Siva sir. So thank you so much. Signing off.